in the enrichment class today, we will, after discussing the general organic chemistry, we have discussed some points over there. We will be discussing a chapter that we are already discussing in the regular classes, which will be easier because the formulas are known to you. The topics are very fresh in your mind. So we are discussing the numericals or the problems regarding the solution chapter. Remember, in regular classes also we are discussing solution chapter. Here also in enrichment also we are discussing the same chapter. I think it will be easier because the formulas are very fresh in your mind, but the type of problems will be much more. The variation will be more over here in this class because obviously it is the competitive format, and we will see there will be some peculiar types which we have not faced earlier in the NCERT exercises or in the CBSE questions. So let us see. Before going into these problems directly, let us remember the formulas once again, the formulas of Raoult's law and the formulas of colligative properties, because it is depending on that only. Let us start today's discussion with a standard problem. The problem goes like this: 58.5 gram of sodium chloride and 180 gram of glucose were separately dissolved in 1000 ml of water. Try to understand that the solvent over here for both the solute is same. Identify the correct statement regarding the elevation of boiling point of the resulting solution. So we are taking this much of NaCl and this much of glucose in 1000 ml of water, which is of course 1 liter, and there are some options what will be correct. So you can read out the options over here. Let us start solving it. Here the problem is regarding the elevation in the boiling point. That means we are supposed to write delta TB is equal to I into Kb into M. Now we are expecting that first we have to calculate the value of Kb and M and I, all of this, but Kb in all this case is for water. So if we want to find out molality of NaCl, then it will be like N by W into 1000. Now this N value, number of moles, should be given mass by molar mass. Now given mass is 58.5. You can see the question here, 58.5. By molar mass is also 58.5 divided by W of H2O into 1000. Similarly, if we want to calculate molality of glucose, here also it is N by W into 1000. Now N, given mass of glucose, here also it is 180 gram. So it is 180 divided by 180 by W of water into 1000. See, both the solution, this value is 1, this value for both of these will be same, 1000 will be same. So if we can write the molality of, if we want to write the molality of NaCl should be is equal to molality of glucose, then we have to accept this. So if they are having same molality, then into this formula, the molarity value for both of them will be same. Kb value for both of them will be same because solvent is same. So molar boiling point elevation constant for water is same for both of this. But I will be 2 for NaCl, whereas I will be 1 for glucose. So what will happen is delta Tb of NaCl will be twice of that of delta Tb of glucose. Because these two values are same, only I will be twice. So the boiling point elevation for NaCl will be greater. And now let us see the options. NaCl solution will show higher elevation of boiling point. Glucose solution will show higher elevation of boiling point. Both the solution will show equal elevation, and boiling point elevation will be shown by neither of the solution. So of course from here you can see option A will be the correct one because NaCl solution will show higher elevation of boiling point because of this higher value of I. The second question is another new type of problem. Please read it carefully. The molar mass of a solute X in gram per mole if its 1% solution is isotonic. We will find it out what it is with 5% solution of cane sugar, which is having molar mass of 342 gram per mole. Then the value of X is following options are given. So in order to solve it, since we know that these solutions are isotonic in nature, so obviously the osmotic pressure of both of these will be same. So for pi 1, that means we can write C1 into R into T should be is equal to C2 into R into T. Now R and T for both of these will be same. So the concentration will obviously be different. So it is N1 V by V1 into R into T. On this side it is N2 by V2 into R into T. Now further, N is the number of mole. So we should be able to write that it is W1 means the given mass by molar mass by V1 into R into T is equal to W2 by M2 into V2. Here it is R into T. So this is the whole scenario till now. Now what we can do is, this is the 1% solution, remember. Solution 1 is 1%, solution 2 is 5%. So if we look into this part, weight by volume part, molar mass over here, if you see the question, molar mass of a solute X in gram per mole. So for 1, if we consider this much is X and W1 by V1, if it is 1%, so we can consider W1 by V1 as 1%. That means it is 1 by 100 into R into T. Value of M1, if we are putting as X, it should be is equal to W2 by V2. It is 5%, that is 5 by 100. M2, that is the value of M2 is, I think for it is for cane sugar, it is given as 342 into R into T. These two will cancel each other out. This one will also cancel each other out. So what is remaining? 1 by X is equal to 5 by 342. So X should be 342 by 5. You calculate, you will get around 68.4. So among all these options, the first option is 68.4. That is going to be correct. So this is the first time we have seen a problem related to the isotonic case. We have to equate the osmotic pressure. We will put the given values over here. In case of cane sugar, almost everything is given. In case of the unknown solution, the M1 is not given, which is X, which we have to find out. That we have done. Next question is related to the freezing point depression, but it is a different kind of problem because of the fact that the question which is given, if we read it out, 0.001 molal it is solution of this one. It is a complex. A complex is given, not a regular compound which we know as electrolytes. In water had a freezing point depression of this much. If Kf for water is 1.80, the correct formulation is asked. We have not seen this type of problem yet, but let us see how to understand this. So the complex is given. Obviously complex and the coordination complex we have not discussed, which is there in the later chapters of class 12. So if this is our desired complex which is given, remember it can undergo dissociation. So it can dissociate. On dissociation, it will be n moles of product. So it will dissociate, it will give some number of moles. What will be the structure of this? We don't know. We have to find that one out actually. So here, earlier there was only one molecule or one mole you can say. After that it becomes n. So the value of I will become n by 1, which is n. So the number of moles of product that this one will dissociate, that will be the value of I. Now, since it is a case of freezing point depression, so delta Tf will be equal to I into Kf into m. The value of I here, it should be n. We don't know. N number of, so I have written n. Kf is given as 1.80, and in the question it is given 0.001 molal. So the value of molality will be 0.001, and delta Tf value is also there, which is 0.0054. Now, if we solve it, it becomes n is equal to 0.0054 divided by 1.80 into 0.001. You do calculate. Calculate it, you will get n is equal to 3. What does it mean? That means if this molecule will dissociate, it will give n is equal to 3 number of moles. That means an electrolyte or whatever compound or complex, whatever if it is, it will dissociate to give 3 number of moles. That means that formula will be correct. Which one can give 3 ions of products? It will be ionized. Now let us see. You see this one. See this one carefully. Cl2 that is there. So if you want to dissociate this one, carefully you see. This one I can write Pt NH3 whole 4 Cl2 plus 2Cl minus. So here there is 1 and here there is 2. So in total there are 3 ions. 2 anion, 1 cation. But see over here, there will be 3 anion plus 1 cation. Not possible. Here there is 1 cation, 1 anion. Not possible. Here only, remember it is 2Cl minus, so it should be 2 plus. So here only, maintaining valency and all, 1 cation and 2 anion can be formed, which is in total 3. N is equal to 3 we have already calculated. So this answer is in accordance with our calculated value. So the correct formulation will be this one. Let us move on to the next problem of today. Here the question is, in a 0.2 molar aqueous solution of weak acid HX, we have considered a weak acid. It can be anyone. The degree of ionization is 0.3. Degree of ionization we can correlate to the degree of dissociation that we have read in ionic equilibrium chapter in class 11. Now taking Kf for water as 1.85, the freezing point of the solution will be nearest to how much of these options. Now let us try to understand this question once again. Here a weak acid is taken. So a weak acid is taken. So acid is mixed with water, of course. Weak acid means acid plus water. That is making the acid weak. So water is the solvent here and the acid is the solute. Molarity is also given. But in case of weak acid, we all know that HX will be dissociated into H plus and X minus. But the only twist is, here it is 1 mole. Here we could have said it is 1 plus 1. Will it be correct? No, it will not be, because it is weak acid. As we know, in case of weak acid, the 100% dissociation do not take place. So what happens? That is why the degree of dissociation, you can see here, it is 0.3, which is given. So we can remember in class 11 ionic equilibrium, we used to write 1 minus alpha, where alpha is the degree of dissociation. Then it should be alpha and alpha. Here also similarly, it should be 1 minus 0.3, and it is 0.3 and 0.3. If we can further remember previous class, then we used to calculate, if we calculate the total number of moles, we used to write 1 minus alpha plus alpha plus alpha, because this is 1 minus alpha and this is the alpha and alpha. So it used to be 1 plus alpha. Here also similarly, the calculation is absolutely same. It should be, if we calculate total number of moles after dissociation, so it should be 1 minus 0.3 plus 0.3, again 0.3. These two should be cancelling each other out. So it is 1 and 0.3, so it is 1.3. So that is total mole. Now I value is the total number of moles after dissociation, and similarly it is the total number of mole before dissociation. So after dissociation it is 1.3, and before dissociation obviously it was 1. So the value of I should be 1.3. That was the thing that I was trying to say. Now in the actual formula, it is delta TF is equal to I into KF into M. Delta TF is equal to I into KF into M. I we are calculating as 1.3. KF we are calculating as 1.85 given in the question. Let us see, it is 1.85 already, and the molality is given as 0.2. So it is 0.2 molal. 0.2. That will be the value of the freezing point depression. Now calculate this much. You will be getting 0.481 degree Celsius. So that is depression, freezing point depression. If we want to calculate, which is the given question, is that freezing point, not the depression, freezing point of the solution. That means now we know that the value of freezing point should be TF naught minus delta TF. You can see this formula. So it should be 0 for water. It is 0.481, which we have just calculated, and this TF value will be minus 0.481. So this will be the answer. Let us see what are the options which is already given. Nearest to, so out of these 4 values, I think the option D, minus 0.480, this will be the correct one.